In this video, I will demonstrate the setup procedure to run the MELSERVO-J5 Ethernet IP servo drive by using Mitsubishi AOIs on the Compact Logic platform. To create this video, I used Compact Logic's L30ERM PLC and two MELSERVO-J5 servo drives. One is a single axis drive and the triple axis drive MELSERVO-J5W3 and with some motors, and the software tools I used MER Configurator 2 and Studio 5000. To do that, we need MER Configurator 2, the versions 1.160s or newer versions of softwares. Studio 5000, we recommend the versions 32 or newer, and Mitsubishi AOI's MELSERVO-J5 Ethernet IP EDS file, and you can download the AOI and EDS file from the Mitsubishi website in here. So in this video, I will cover enable the Ethernet IP protocols, IP address settings, register the EDS file, creating a Studio Projects 5000, add the Mitsubishi Drive in the projects, import the Mitsubishi AOI, and create a PLC program, execute the program. First, let's connect the USB cables between the servo amplifier and the PC, and then turn on the power and open MER Configurator software. And create a new project. I have a single axis and a triple axis. My single axis is connecting right now to my PC by USB cables. Just choose the model MELSERVO-J5 single axis, then click OK. Now go to parameter settings, and then from the list display, network settings, and set PN13 parameter to 8 to activate the Ethernet IP protocol. Then press the tab selected item right. After writing complete these parameters, you can recycle the power or you can press the software reset tab. Now click the network parameters settings from the projects window and set the IP address. First, disable the DHCP, so you have to choose the user parameters and then set the IP address as you wish. In my example, I would like to set the port octet is 151 and write the parameters by clicking the right tab in here, and then execute the software reset. Now you can see under the diagnosis tab system configurations, and you can see the IP address is set 192.168.1.151. So similarly set for triple axis. Then similarly connect the USB port triple axis drive, then enable the Ethernet IP protocol and set the IP address. And set the IP address 192.168.1.152. After IP address settings complete, you can check all the amplifier through the MR configurators via Ethernet. So just create the new projects, click the network control, click OK, and set the Ethernet IP, the connections network automatically detect the amplifier that is connecting in the network. So in my case, I set the IP address 151, so I want to set 1 to 160, I mean 150 to 160, and then hit the detect now tab. Now the MR configurator found two drive, the single axis and triple axis drive, and IP address settings 151 and 152 fourth octet. So now you can select OK, and you may select again OK. Then you can see all of the amplifier in the one projects. You can do the tunings, and you can check the diagnostic system configurations. You can check everything's IP address and all other things. After IP address setting completed, let's register the EDS file. First, download the EDS file from the Mitsubishi website, and then open EDS hardware installation tool. Then click Add tab and choose the register a directory of the device descriptions file. Browse. I download the EDS file and AOI in the download folders. Double click. So this is my EDS file. Click OK and click the next tab. Now all the files in this folder is pop up in here. Click next. So that type of device is supports single axis, common DC bus type, and also double or multiple axis. Then click next. Then click the finish tab. So that will bring the EDS file, all the drive profile in the studio softwares. Now launch Studio 5000. Click the new project. Choose the PLC type is a compact logic 1769 L30 ERM, that is connected. So compact logic 5370 L30 ERM. Then enter the project name. Click. After enter the name, click the next tab. Choose the revisions. I'm using the 33. Then click the finish tab. Now add the Mitsubishi Drive in the projects. To do that, right click in the EtherNet tab. Click the new module. From catalog tab, search MR. So all the MR drive will be found in here. We are using the single axis J5. Double click or create tab in here. Give the drive name. set the IP address. If you recall, I said the port octet is 151, and the one option so you can change in here for electronic key. Sometimes your power versions and EDS file does not match, then you need to disable the electronic keying, then click OK, then click OK, and then OK tab. So the one drive already add, then add the second drive. That one is a MELSERVO-J5W3. Double click in here, give the drive name, and similarly set the IP address 152. That's I set. This is optional. Then click OK. Sorry, I have to give the drive 2 the name, and click OK. The 2 drive is added, so that I have in my network. So now close this new modules window here, close. Now you can see the 2 drive control tag is created in there. So drive 1 is for single axis and drive 2 for triple axis. Now import the Mitsubishi AOI in the projects. So download the AOIs from the Mitsubishi website, then right click on add-on instructions, and then choose the import the add-on instructions. I download the AOI and it is in here, versions 2 under the AOIs. So you can import the single AOI, or you can import all AOI in the same time. So to do that, select all AOI and then hit the open tab. So it is reading the file. So in here keep it defaults and click OK. That will start importing all the AOI in our project. So all the necessary AOI, everything's in our projects. So one important things we have to do in here. So as you remember, we have the 2 drives is connected in there. So this AOI you can control J4 and J5. So what we have to do, so MCOM Mitsubishi is for J4, so we don't have it, and also that one we don't have dual axis drive. So I would like to delete from the AOI list. So now I have 2 MCOM, one for J5 and one for J5W3. So in futures, if you need the others AOI that I just delete, so you can simply import the AOI from in here. An example, Mitsubishi MCOM or MCOM AOI for J5W2. Now create a PLC program to establish the link between the AOI and the drive. In the main routine, drag and drop the MCOM. So I add in here 2 MCOM, one for J5, one for J5W3. Just create a tag for MCOM for J5 single axis. Instead MCOM drive 1, right click in here and create the new tab. You can have this tag in a local or in the project, under the projects. So I'm going to keep it in a local right now. So say create, and then link to the axis on I/O to the drive 1, this drive 1 I/O. So drive is a single axis. Now I'm sorry, it will be, and similarly axis out will be local top as a drive I/O, drive 1 output, and then creating another tag for servo 1. That tag servo 1 will be the use the Mitsubishi, use the all of the AOI. That will be linked to the all the AOIs. So right click in here, servo 1, and then I'm going to keep it in the global variables, global tag, then hit the create tag. So basically that is for single axis one. Now similarly I'm going to make it for second MCOM I for triple axis. I just create, I give the drive 2, and similarly I have to link with the control tag in here. So drive 2 I/O input and drive 2 output, and then I have to give the name of the axis that will link to the all the AOI. So first one servo 2 A axis. So we have a 3 axis. So right click, and then there is a Mitsubishi servo, create one, then just make it 2. There is a B axis, and then create a tag for servo axis 2 underscore B, and I forget to create a new tag for MCOM for triple axis. For this reason, this error in here. So let's create the MCOM tab in here, put in the main program, then create, so that is happy. So basically now I create the 2 MCOM AOI. Keep in mind this MCOM AOI you have to call all the times, every scan of the PLC. And from in here you can monitor the axis status, error warning, and ready status, as well as position, speed, and torque. After that you have to add the Mitsubishi Drive configurations AOI that will set all the necessary servo parameters. And so you have to have for every axis you have to do that, and this AOI you must have to execute once, and then we need to do the recycle power. So let's add Mitsubishi configurations AOI, drive configurations AOI is in here. Just click in here. Now create inst config 1, right click, creating the tab, main program. Then you have to give the axis name, Mitsubishi axis name. So you can remember servo 1. I have that. Now we have to give all the value we want to set. So let's say if you set 0, that means it will not write the torque limit value. So let's say I would like to put 300%, so you have to set 3000. So that's mean one decimal point. In here you have to give the number of encoder pulses and travel distance based on your system. In my case, I want to use 1 revolutions is the 1 inch, so I want to set the encoder resolutions in here. So 67108864 for the encoder resolutions for 1 revolutions, and I want to move 1.0 inch, and then basically I want to disable the limit switch, so set to 0, software limit switch exactly same, and then auto tune response. As you know, by default servo amplifier has a auto tune mode 1 and the response setting is a 16. So if you want to set something else, so you can set the value in here. In my case, I set 20 absolute encoders, so I want to set 1. So gearing, J5 does not support the gearing, so I want to set 0. And finally, and the user unit. So user unit is 1 for inches, and you can check in the manuals, and the motor rated speed. As you know, I just have to give the motor rated speed because we have different motors. Step of our argument, if you are using the some motors the rated is with 2000, you have to use the 2000. In here I am using the KT motors, my rated speed is 3000. So now this AOI complete. So I create the global, call this AOI once, create this tag, and just create. So this is for axis 1. So also I have another axis, so I want to create similar things I want to do for other 3 axes, but in this case I want to give you the 3 axis example, one the single axis and 2 axis from the amplifier 2. Let's copy and paste. Let's see it's work or not. Yeah, it did work. So let's creating the tag for axis 2. Right click, new tab, click OK. Keep in mind we have to define a different instance for the single AOI. So I in here create and I keep the main program. So now you can see I create that, so different axis but the same axis, so I have to set servo 2, I believe we give the name. So now I'm writing the servo 2 axis A, and similarly I will copy and paste, and I will do the 3, the instant name, create a new tag, the create tag, and the B, set the axis 4. So this is, that one is for my 3rd axis. So 4. Create instant of 5. create this maybe I need to put in a global create and give the different name. Okay, so I have configured all the 4 axes in here. Basically that's you need to configure every project. You have to do this initial step. After that you can use the AOI. And normally let's download these projects, and I'm going to show you, I'm going to execute the MC configurations, then I'm going to do some move later on. First things, let's download the projects. The communications go online is definitely fail. And the new projects, my path is not select, so from here oh, I see my PLC was not powered on. Yeah, so this is my PLC. Let's select that and go online, download the projects. While it's downloading, I'm going to show you in my amplifier. So in example of the axis 1, let's read all of them, select all, read. So you can see all the parameters is default. Let's see in the projects, and the program is download is complete. Let's see. Now we can see the communications are both are okay. So there is a warning. I believe this warning is showing because all the drive is in default. So it has let's see in the amplifier. So if I go to the diagnosis, alarm display, you see it has E6, the force stop warning. So in here the AOI add on in here, so in the E stop switch, so I set the 0, so that's mean I am disabling, so that will be taken care after I write all the parameters. Let's execute the parameters for single axis 1, toggle. Yeah, see it's complete. Now you can go to the MR configurator and read the parameters for single axis, select 151 for my axis, then read. You see all the parameters is written in here, and then you need to recycle power. So I'm going to do the same things for all others axes. So toggle, so it's complete, then third one, and then complete, and then my second drive in the C axis. So now the toggle. Now we can go to the MR configurator again, read all the parameters, select all, read. See all the axis necessary parameters is already set. Now you can reset the software, so you can do all at a time. So select all of them by select button and click OK. And that's it for now, all the parameter settings, and now you can do some programming. Now you can see the axis has the error. Let's see the servo diagnosis, alarm display. So it has absolute positions erased, so that's when I set the absolute position system. So we need to do the recycle power one more times. Let's do that, all 4 axes. Now just wait a little bit in here. So error is clear. Now we good to go, so we can do some programming. Let's make servo on in here, and a copy paste from my other projects, so we can easily do that in here. So I need to do the servo on for, let's delete that, so make it so servo on, so axis 1, axis 2. So let's see in here, just create the instance of MSO. So servo on for axis 1. I'm gonna make it in a local tab in here. This is for second axis for instant. Create. So this good. This all of them is making a servo on. That will be the servo up. Similarly, creating the tag for MSF servo up instructions. Create. Is good. So let's download this too. Okay, let's see we can do the servo on or not in here. So toggle the bit. So the servo axis 1 is on, and axis drive 2 it doesn't on. I'm gonna check what's going on in here a little bit, so you can see in here is ready. So there is have some warning. Let's see, go to the MR configurator. I see, so I did not power on. So let's do the main power on, and I'm gonna do the servo on again. Let's see. Now I turn on the main power of the servo axis 2. So you can see now there is a warning is go away, and axis become ready. Axis 1, axis 2, and axis 3 is not ready. Yeah, I see, you see I did make it servo 1, A and B, and so that makes sense. So axis 1, single axis is servo on, drive 2, axis A and axis B is on, and axis C it does not turn on. Okay, now let's add the jog program in there. I copy paste from my another projects. So this is 2 axis jog. Just let's create a couple of some tag in here very quickly. Okay, and in here new tag, create, and directions, here the directions and instant of jog. Let's do the create servo 1 direction. So I don't have a speed. Let's make it a speed. Getting that acceleration. this. Okay, so the jog is 1, and then you have to, the jog is a speed mode, and you have to provide the speed stop command when you stop the jog. Let's make it instant of the jog. Stop MCMS stop in here. Similarly for axis, second axis, very quick. One more, I have to create the instant for MS. That's great. So now it's good. Now I'm able to do the jog, download the projects. Yeah, so it's successfully downloaded. So now set the directions. 0, I think is a 0 is a forward. Set the speed. Speed 1 means 100 RPM, and set some acceleration. So 100 sorry, speed 1 is 60 RPM based on our parameter settings, and the direction similarly set the speed for the second axis. So then this acceleration, and then some deceleration settings. We're gonna run jog forward with the toggle, and then jog. Axis 1 is jogging. Similarly in the forward, and axis 2 also. This 2 is jogging. We can verify in the MCOM. This is the servo is moving, and 1 inches per second. Similarly, your second axis is moving, and also we can verify with the MR configurator from monitor display all. So you can see the servo motor's axis 1 is moving the 60 RPM, and drive 2 and axis A is moving the 60 RPM. If you want to stop the jog commands, successfully stop. Similarly for my second, and this is for jog. Similarly I can make it like a home. So let's add some homing routines in here. Similarly, I'm going to copy paste from my other projects. This is a to home. Same things in here, and create instant of the homing function blocks for axis 1. Similarly, instant of homing function block for axis 2. So that one is good. So maybe in here I have one dummy bit I just set so that I can monitor the positions. So you can see the servo actual positions, speed and positions. So my goal is after I do the home, so I can monitor the positions in here. Just set, and in here, so the homing speed you have to set some value, let's say 1 inch per second, and then previous speed is that. -11 is the homing at the G pulse. Similarly second home instant, so 2 RPM, 2 inches per second, and maybe in the set. Let's do the home for first axis. You see the homing, and homing is complete and position set to 0. Similarly, I'm going to do the homing per second axis. So you see homing is complete. So now the position set to 0. Now you can use the MAM, all kind of function blocks you can use. So I would like to recap. So couple of things. One thing, you have to have the you have to have the drive communication function blocks. Always you have to run every scan of the PLC, and then you have to configure the drive using the MMCFZ drive configurations function blocks and set the proper value. I think I cover very much everything. If I miss some things, we can download from Mitsubishi FA or Mitsubishi USA website, and I put in all the quick start guide in our website, and then you can find all the details. Yeah, that's it for today. Thank you very much for watching.